This is an example of the workflow being applied to the dynamic tile generation and serving of AIS shipping traffic and comparing it to a deployment of drift buoys in the Gulf of Mexico and a brief explanation of how this is being done. So we're starting with a map view. I have a pretty broad scale right here because I want to show you that we have the entire United States shipping traffic data as pulled or downloaded from marinecadastre.gov/AIS. And this could be done on the fly. We could pull directly from their server, but we want to respect their bandwidth limitations, so we have downloaded the files to a local directory, which actually, believe it or not, makes things a little bit slower because of all the file opening and closing. But in any case, here we are. If I relocate the time scrubber on the bottom, you'll see the data set changes. This is several months of shipping traffic data at about 1 to 7 million records per day. So we have about 90 days. So if we go back, I want to show you what else we have in here. So I'm just going to start animating this at a time scaler of 2,000 times. The data are sampled every minute, roughly, from the shipping traffic data. It's not exact, sometimes lower, but never really more frequent than that. So when we have a time scaler on here, we're accelerating the playback not uniformly across all of the vessels because they have variable sampling. But in any case, the generation of the tiles is being done at the speed of the scrubber. So if I were to come through quick enough, you could see I can actually outpace my ability to provide the tiles, but when I stop, they catch up. So we're going to play that at 2,000 times to see what happens. And we can see as this flickers, that's another time-stamped tile data set. So we have binned these data in time at the interval of 1 hour. So every time there's a flicker, that's another hour passed or another hour of shipping traffic data. Now we're seeing the buoys being deployed in that data set. And we can see that happening as the shipping traffic is animated. So this is a much heavier load than a real-time stream, which is the same identical workflow for the shipping traffic in the way that we've implemented this. So we can see at this level, at hourly data, that we can see segments of data which represent a unique vessel. And we do have the ability to click. I haven't brought it up to the interface yet, but we do have the ability to click on one of these points and pull the metadata forward to actually identify that vessel or vessels. So the aim here was to see if any of these vessels were interacting with the buoys. And we can see that, yes, there are some that do. And these buoys are measuring environmental parameters at the sea surface, such as temperature, pressure, wave period, et cetera, et cetera. And they are drifting in the Gulf of Mexico's loop current as we see them now. They're not powered in any way for maneuverability, only for the observation of the sensors. So as I zoom in, you'll see the fidelity will change. I'm going to ignore the buoys for a minute. And you'll see there's a color scale in here, which I'll explain. We've actually mapped or aggregated the data into the red, green, and blue channels of each map tile. We're doing that on the fly here. So the aggregate actually contains the point count in the red channel. So it's the point count per pixel, and the pixel has a different geographic footprint depending on your zoom scale. And you can see that in the fidelity of the data. So if you zoom in far enough, your point count is only ever going to be 1 because you've actually zoomed in to the level of data where you can actually see individual data points. So the red disappears in that sense. The green channel is the average speed, whether it's for a single vessel or a group of vessels. It represents all vessels in that pixel. And the blue channel is the standard deviation of the speed. So as we zoom out, we get a little more insight into that. So we can see the channel in the Mississippi River will start to become a little more blue because the speed is highly variable in the shipping channel, whereas offshore speed tends to get fairly static and it becomes green. So the standard deviation goes down, the blue colors go away. The red is not present because there's a single entity, and so the speed becomes the dominant attribute in the color, and it is fairly constant, so it just maintains a green shade. So you can see that here. There's blue in the channel, there's green offshore, and if you were anchored, for example, as we can see here, then you would have mostly red because you are stacking up multiple points per pixel from a single vessel, and it's not really moving. You will see over time these will start to delineate crescents as the tide pushes them around their mooring. We do have other layers in here that we can look at along with the buoys. So we have the fairways from the BOEM website. This is a shapefile with metadata, so we can actually pull that information forward. We also have the oil and gas pipelines, and they have been scaled to the size of the pipe, so you can see some of these lines are thicker than others. We can see who owns it, what it moves, what its size is. By comparison, here's a smaller one. We also have the oil and gas pipelines. The platforms. So we turn off the pipelines so you can see those. And we can pull that metadata forward as well. As we can do with the buoys, which you can see the buoys are changing color. We've mapped the temperature attribute to the buoy, so as the time of day changes, you'll see the sun as a governing factor here. During the day, the sea surface temperature heats up, and at night it cools down. So we'll see them oscillating throughout the day from warmer to cooler. And we could also look at other layers. Here's a fused bathymetry layer. And lastly, I want to get into the technical part of this. We have the tile coordinates. So we're actually optimizing this workflow by capitalizing on the map tiling structure. So here we have at the zoom level 7, we have a tile coordinate 32 and 53 for this tile. And these tiles are 256 pixels by 256 pixels in each direction. So in addition to the zoom level and the tile coordinates, there are also pixel coordinates within each tile. And lastly, there's the timestamp. So all of those dimensions are the dimensions that we bin the data on when it's ingressed. So this works for streaming data just as well as it works for archived data. When the data hits the platform, these bin chains are appended to the data, and it is passed along either to a client or to a processed workflow. So this can be cached or it can be streamed without any additional change or without significant change in the workflow. So we could go to other parts of the world if we wanted to, or in this case, the United States. And we can see these tiles are being generated and served dynamically. So it's fairly responsive. So even though as earlier I could grab this time scrubber if I move too quick, we're dropping tiles. At least at a 2,000 times scaling in time, we're able to keep up. So this is very performant. This is on a single system. This is not in cloud infrastructure at this time. So imagine how powerful this scales if this is what's happening on a single device. Now, a look at the directory structure. So this is my tile repository, and you can see I have zoom levels in there. So if I look in each zoom level, you'll see two things. One, you'll see a very large number of epoch named databases. So these are the timestamps. Each number in here represents 1 hour of data. And inside of that file is the bin chain, all stored as integers, and the aggregate. So we have the red, green, and blue channels, as I mentioned before. The point count was in the red channel. The mean of the speed is in the green channel. And the standard deviation of speed in the blue channel. And having this bin chain accessible here allows us to very quickly extract this information per tile. So the way we are hosting this data is we are sitting and listening on a socket, in this case port 8080, for a maptile URL, which would be in the format of hostname :port /tiles /epoch /zoom /x /y.png. So it's your typical maptile URL format with the addition of a dynamic epoch. And that information will then get passed along to a function that will retrieve either a cached tile, if that's an option, or it would generate a new tile on demand. So here is how that works. So if we're passing in the epoch, the zoom, the x, the y, basically the bin chain, then we can go and check and see if we have an image tile from another type of database, which is where we would store the images. And we could also store the aggregate per tile in here as well. So that would be a blob of the image at some timestamp, and that would be the primary key. So you can see in this case we're not populating this. So we are definitely generating all of our map tiles directly from the bin chained aggregated data per timestamp. So we'll have one of these every hour. So if there is no image in a cache to provide, then we'll go ahead and generate it directly from those databases. We're just populating the normalized data into the red, green, and blue channels and adding an alpha and sending that as a binary byte stream directly to the client, and it will be in a ping format. And that's it. We can do that for other data layers, and they are hosted in your typical maptile format. And this is highly performant. I'm very excited to have had the opportunity to share this with you. And I look forward to advancing this to new levels and scales. Thank you.